In this video, we're going to go through some of the symbols that you're going to see in circuit diagrams. And this is really important in that you have to know what these symbols mean, and you have to be able to draw them correctly, interpret them correctly. So the first one we're going to talk about is the battery. And one of the things about the battery is that it's one of the very few components we are going to deal with in here that actually has an orientation. So the positive part is actually the bigger end. So you note that one end is longer and one end is shorter. Now, honestly, I find it really challenging to remember which is which, since I frequently think of that shorter end as being like the little pokey bit of the battery, but that isn't actually how it works. The other thing is that you're sometimes going to see it just as 2. There's nothing special about it being the 4 here. There is a subtle difference that we're not going to worry about. So notice that it's actually labeled, that end is positive, and this is going to really matter for how we think about our circuits, to think about the direction the current is flowing. So the orientation matters on the battery. In general, I will try to actually label which one is positive if I'm drawing the circuit diagram, and all of the ones from the book should be labeled. So make sure that if you're drawing it, you get the orientation correct, that you have the correct sign defined as positive if you know which one that is. So that's the battery. Orientation matters. Be careful. Now, a wire is just a line. That's really not too challenging, but notice that this wire was a little bit curvy and this wire is straight. So we're frequently going to be simplifying our wires, and often we're actually going to not worry about the spatial position of our components whatsoever. And we are going to have later in the video some examples of that. Now, the last example on this slide is the resistor. Now here it's shown just as a cylinder, but what you've actually seen in class is that there's going to be some colored bands. So a real resistor that you might see in front of you would have bands like this: brown, black, red, and then gold. The brown, black, red would be a 1000 ohm resistor, and then this is the 5% tolerance, which you worry about in lab, but we're rarely going to worry about in actual calculations. So we know that this is then 1000 ohms, which we normally would call 1 kiloohm. And so in that case, we would want to label the component on the circuit diagram with the specific resistance. So the symbol we use for the resistor is this little jagged line. Again, there's not going to be a specific interpretation if you draw it with fewer zigs or zags compared to normal. I'm really bad at drawing, so mine usually look like that. So I don't expect you to do better than this, but this is roughly what we're going for. So these are 3 really important components, but there's a few more to think about. This first one here is a bulb. So in this case, we mean a light bulb, and as I've said a few times, a light bulb is not the same thing as an LED. And now notice that with a light bulb, you actually have a path to the bottom, and then there's actually an insulation so that the bottom does not touch the side. You have these loops on the inside, which then goes to the side. So in lab, when you make connections to the bulb, one goes to the side, one goes to the bottom. So now what you should see is that these curly cues here go into our symbol. And again, depending on what program the circuit diagram is drawn in, or if you're drawing it yourself, I typically would draw it with a circle and then some little loops in it, but 1 versus 2 versus 3 loops really doesn't make a difference. But again, the goal in our circuit diagram is to not try to draw a real-world representation of what you have, but a simplification. So a junction is simply where you have more than one wire connecting, and again, that's going to look like multiple straight lines connecting. So that's not too hard to worry about, but again, we don't have to really worry exactly where the wires are connected if they're really right angles or not. Those pieces of information do not matter for our circuit diagrams. Our capacitor, you're going to see this symbol, and you've seen this symbol earlier when we were talking about parallel plate capacitors. Note that this will always look like a parallel plate capacitor, even if we're dealing with a capacitor in the lab that doesn't look like this. So capacitors can look really different. They can be kind of big and flat, maybe red or gray or brown or tan or blue. Maybe they're going to be small cylinders. In any case, this is always the symbol that you use. And again, if you know what type of capacitor it is, for instance, a 1 picofarad capacitor, you would want to label it. The last symbol here that we're going to worry about is a switch. Now there are many different types of switches, and we are going to work with fairly simple switches in this class. So this is one. So it's either open, which means no connection is made, right? You need this metal piece to be in contact with that metal piece for there to be a connection. So this is open. Now another option is that you want to show the switch closed. Well, what would that look like? That would look like that. That's a closed switch. Sometimes we want to represent that the switch is in the process of closing. You would maybe draw an arrow. And sometimes you might want to show a switch that can go between more than one option. So that might look like this, something like that, where this is, for instance, connection A that it can make, or this part can actually go down and make that connection. So there's a few different options for switch. This is the simple one that we're starting with. You might see the closing or opening switch in the circuit diagrams I make, and once in a while in this class you'll see something like this.